Hey yo, how's it going guys? Tech with Joel here, and in today's video I'm going to be teaching you guys how to create a sketch image from an original image using Python. So this image over here, this image called demo, we're going to be converting it into this sketched image over here. So yeah, without further ado, let's get started. First, we'll need to install our libraries. So the library we're going to install is OpenCV. So we're going to do pip install OpenCV. Just in case this command doesn't work for you guys, you can do python -m python-m and then pip install OpenCV. And just in case this command doesn't work for you guys too, you can do python 3-m pip install OpenCV. If it doesn't work, then you can check your Python installation if it's in the appropriate path. So without further ado, let's get started. So I'm going to come over to my editor. You can choose any editor of your choice. I'm going to use the Python's install IDE for some reasons. So yeah, let's get started. First, we need to import our library we installed. Remember, we installed OpenCV, but if you want to import it, you don't do import OpenCV. Instead, we say import CV2. That's how we import OpenCV. After that, we need to specify our image. Remember the image over here that we're going to convert into this sketch image here, right? This demo image over here was converted into this sketch image over here, right? So I'm going to specify the demo image and then convert it into a sketch image. I'll just remove the sketch image right now so that I'll show you guys the process of converting it. So I'm going to specify the image. I'm going to say image is going to be equal to cv2.imread. Okay. So just in case you guys don't know what the imread function does, what's the imread functions? What it simply does is that it takes in an image. For example, for our is demo. It takes in an image part. Actually, my own is a JPEG file or JPG file. So it's JPG. What it does is to take in an image part and read the data inside. So after that, I want us to visualize our image that we just imported. So I'm going to say cv2.imshow. Okay. Now, what the imshow does is to create a window, and inside that window it's going to put our image in it so that we can view it. So the title of the window is going to be original image. Okay, that's what I'm going to call my window. It's spelled ORIGINAL. Image. And then the image that we're going to show. So first, the first argument it takes, or the first parameter it takes, is the name of the window, and then the second parameter is the image. And the image we're going to show is this image over here, which we loaded from the demo.jpg, which is this image right here, right? This image over here. So yeah, let's get back to our code. And then after that, we need to show our image. We need to create the window actually. So I'm going to say cv2.wait key, and that should be equal to 0. Okay. And then after that, I'm going to say cv2.destroy all windows. Now essentially what the wait key window does, wait key attribute does, is simple. What it simply does is that in order for our window to stay on the desktop, we call this function, this attribute. It keeps our window on the desktop, and this 0 over here is the number of milliseconds. So if I should put 1000, our window is going to stay up for only 1 second. If I should put 10,000, it's going to stay up for only 10 seconds. If I should put 0, it's going to stay up forever. And this destroy all windows here simply tells our window that when the X button is clicked, which is the exit button, it should close the window. So that's what our function here actually does. So I'm going to save it, I'm going to run it, and let's see our window. And here we go. As you can see, we have displayed our image over here, and the title give our image original image. As you can see, it's up here, and then you can see our image being shown over here, right? can maximize it, minimize it, and stuff like that. That's what OpenCV gives. That's the flexibility OpenCV gives us. So now, take note that we're converting our image into a sketch image. So first, in order to convert that our image into sketch image, in order to make it a little bit more simpler, since the image is colored, we're going to convert it into another color space like gray, and then from gray we can blur the image and then make the image sketch. So it's way more easier like that. So I'm going to say convert. I'm going to put this comment here to make things easier for you guys. So I'm going to say convert from one color space to another. Okay, and I'm going to say gray image. Our gray underscore image is going to be equal to cv2.cvt color. cvt color. And just in case you guys don't know how I open this little window over here, you can just do control space. It works in Sublime Text Editor, it works in what you call it, Visual Studio, it works in also this IDE that comes with default Python. So just do control space and it's going to open up this little window for you. So after doing that, we're going to put angle brackets right here, not angle brackets. We're going to put parentheses, right? And then after, I'm going to specify our image, which is image, okay. And then after that, we're going to convert our image to gray. So I'm going to say color cv2 actually dot color underscore bgr to gray. Now, what this code actually does is straightforward. From the cv2 color, we'll call an attribute called color bgr to gray. Actually, if you guys work with CSS before, any other editing framework, you know the RGB colors, right? Red, green, and blue. So in OpenCV, RGB is being recognized the other way around. Instead of RGB, OpenCV sees RGB colors as BGR. So instead of red, green, and blue, OpenCV sees it as blue, green, and red. So in order to convert our color space to gray, instead of saying RGB, we're going to say BGR to gray. So essentially that's how it works. And after that, we're going to say invert. Invert is going to be equal to cv2.bitwise. Try cv2.bitwise underscore not. It's going to be brackets gray image. If I can type correctly. And then after that, let's just visualize our gray image. As you guys remember, we use the cv2.imshow to show our original image, right? Now let's visualize the gray image. Since we have converted it into gray image, what we can do is we're going to say cv2.imshow, and then we're going to put the image we want to visualize, right? Which is going to be our gray image. So I'm going to say gray image, right? After, I'm going to say gray underscore img, and I'm going to save. I'm going to come over, I'm going to run my code actually. So it's Ctrl R to run. And here we go. As you guys can see, this was our former image over here, right? Which was titled original image. Now we have converted it into gray image, and then we visualize the image. So as you guys can see, the title is gray image, just as we specified there, and the image has turned to gray. So it will be way more easier to turn this image to black and white and then trace all the edges and turn it into a sketch image. So let's do that. Next, we are going to make the image smooth. So I'm going to say, let me add a comment. I'm going to say image smoothing. Okay, not smoothing. image smoothing. And then in order to make our image smooth, what I'm going to do is to add blur to it. So I'm going to say blur is going to be equal to cv2 dot, actually cv2 not cv3 dot Gaussian blur. Now what the Gaussian blur does, it's also in Photoshop. So if you guys have worked with Photoshop, it adds blur to our image. That's basically what it does. So I'm going to do invert, which is this our image, which is this variable over here, right? And then I'm going to add these values over here. I'm going to say 21, 21, 0, 21. I'm going to add 0 over here as the third argument. And then after that, I'm going to say inverted blur. It's going to be equal to cv2 dot bit wise not, okay, blur. So yeah, this is just the process of converting our image to blur. You guys don't need to worry about this piece of code. And then after that, I'm going to say sketch. Or you know what, let's view our blurred image first before converting it to a sketch image. Let's view it. You can say cv2 dot im show, okay, and then I'm going to say blurred image, if I can spell correctly, and then I'm going to say inverted blur. Save our image, save our code, run our code, and then let's see what it produces. And here we go. As you guys can see, our original image formally, and then we converted from our original image, we converted into a gray image, right? And from our gray image, you guys can see our blurred out image now. Now our image is blurred. All the imperfections are dulled out. So it will be way more easier to trace out all the lines of this guy's face and make it a sketched image. So let's go back. Let's do sketch, right? We're going to say sketch is going to be equal to cv2 dot divide, and then I'm going to say our gray image, right, underscore img, our inverted blur image, inverted blur image, and then I'm going to give it a scale. Let's give it a scale of let's go with 256.0, okay. And now let's view that image, our blurred image. So we can do cv2, actually cv2 dot im show, and then first we can say do sketch image, and then we can do sketch, okay. Save the code, run the code, and now let's view it. And here we go. As you guys can see, our original image converted into a gray image. From our gray image, we converted it into a blur image. From our blur image, we divided the image, added the gray image and the inverted blur image, and this was what it produced, our sketched image. Now you guys can see that the image is sketched, but if you notice, the image is not saved over here. Remember when I was showing you guys, when I started this video, I showed you guys the image, right? But it's not saved over here. In order to save our image, is simple. What we're going to do is we're going to say, let me put my windows side by side in order for you guys to see how the image is being saved in real time. So I'm going to put it here, put this window over here. Alright, I'm going to remove all the im show whatever, so that I won't obstruct us. So the code I'm removing is the im show, which shows our image, okay. And then after that, we have to save our sketch image. Let me create a comment, say save our image. We can do cv2 dot im. You guys remember we said im read over here, right? Which reads in data or takes in data as input. In order to put data as output, you can say im write, and then of course it takes in the name of the image you want to save and the image you want to save. So the name of the image you want to save is sketched image, okay? And then the image we are saving now is our sketch. All right, and after I'm going to save, and before I run this code, let me adjust my window a bit. So now I'm going to run my code, and you guys should watch. Our image is going to be saved over here, so let's wait for it. Whoops, looks like I made an error over here, so I'm going to check what went wrong. cv2.im right sketch. Oops, I forgot. We are supposed to save it as an image, not. This is what I made. I'm going to say sketch.png. I never give it a file extension. So because I did not give my image a file extension, that happened. So you guys should not forget to give your image a file extension and also the name of the image too. So I'm going to save the code and run it again. Come over here, and you guys should see our image appearing over here. So let's wait for it, and here we go. As you guys can see, our sketched image is shown over here, right? And also we can also choose to save our blur image too. So we can change this to, let's say we want to save our gray image. I'm going to say gray.png, right? I'm going to save the gray image, so I'm going to say gray image. Save this code, run it again, and then we should see our gray image appearing over here now. And here we go. As you guys can see, our gray image has appeared. That's simple. So you guys can mess around with OpenCV. This is just the tip of the iceberg of what OpenCV can do. Just like I said, OpenCV is mostly used in machine learning and AI programs. So if you guys want me to release a full-blown course on OpenCV and the possibilities, please don't forget to write it in the comments. And also, that should be it for this video. Don't forget to like and subscribe. And I'm running low on subscribers, so please, this is actually a relatively new channel, so don't forget to hit the like button, subscribe, and I'll see you all in the next one. Until then, take care and happy coding.